Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n cubed plus n squared is equals to 810, and we will solve this problem for the real values of n. So in this question we will find only the real roots of this equation. So the very first thing we are going to do is, here first we will focus on the right hand side, and in the right hand side you can see that we have 810, and we can write this 810 as 81 times of 10. And after this step we can write this 81 as 9 squared times of, we will write this 10 as 9 plus 1. And now we will multiply this 9 square on both of the terms, and you will get here 9 cubed plus 9 squared. And now I can replace this 810 by 9 cubed plus 9 squared, and we will get its output in the form of n cubed plus n squared is equals to 9 cubed plus 9 squared. And after this step I can make the pairs of a cubic term and the squared term, so that here first we move both of the terms in the left hand side, and we will get n cubed plus n squared minus 9 cubed minus 9 squared is equals to 0. And now we make the pair of cubic and square term, and our pair of cubic term is n cubed minus 9 cubed plus the pair of a square term is n squared minus 9 squared is equals to 0. After this step I can use here the nice two formulas, the which one is cubic and other is square identity. And you know about the cubic formula, which is, if you have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b squared. And the other formula which I can apply here, which is a squared minus b squared, it is equals to a minus b times of a plus b. So now I can use here these two formulas in the above expression. So first I can apply here the cubic formula in the first term, so that our first term, which is n cubed minus 9 cubed, will becomes in the form of n minus 9 times of n squared plus 9n plus 9 square, and plus here you have 9 square minus n square, and here I can apply this formula, so that the output of this will be written in the form of n minus 9 times of n plus 9. And now you can focus on both of the terms, and you will see that we have n minus 9 be the common term, so that we will take it common, and you get its output in the form of, here you get n squared plus 9n plus, here you have 9 square, and 9 square is equals to 81, plus here you take common n minus 9 and you get n plus 9 only, and this whole is equals to 0. And now we will simplify the terms, and here you obtain 9 minus n times of n squared plus 9n plus n will be equals to 10n, and 81 plus 9 is equals to 90, and this whole is equals to 0. And here we have two cases. The first case is we take n minus 9 is equal to 0, and the other case is we take n squared plus 10n plus 90 is equal to 0. And in the first case you get the value of n is equals to 9. So this is the first real root of the given equation. And now in order to find the other real roots, first I can check this quadratic equation has real roots or not by using the discriminant formula. So that here we have a is equals to 1, b is equals to 10, and c is equals to 90. And you know about the discriminant formula. So the discriminant formula will be written in the form of delta is equals to b squared minus 4 times of ac. And now first I can explain little bit about this delta. And you know that if the value of this delta is less than 0, then we can say that this quadratic equation has no real root. So just I can write here it has no real root. And if this delta the value of this delta is greater than 0, then we can say that this quadratic equation has two real root. And similarly, if our delta is equals to 0, then we can say that this quadratic equation has one real root. And now we will check the behavior of this delta by putting the values of a, b and c in this formula, and you will get the output in the form of, here you have delta is equals to b square, and the value of b is 10, so it is equals to 10 square minus 4 times of ac, and the value of a is 1 and the value of c is 90. So now we can simplify the terms here, and you get 10 square is equals to 100 minus 90 fours are 360, and 100 minus 360 will be equals to minus 260. So the value of this delta will be less than 0, and here I can say that if our delta is less than 0, then the given quadratic equation has no real root. So that here I can just write the given quadratic equation has no real root, or it means that it has complex roots. But in this question we need the real roots only, so that we will rejected this case, and we can just proceed here this case only. And in this case you have the only one value or only one real root of the given question, which is n is equals to 9. And this is the our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.